organic chemistry. What is organic chemistry? Organic chemistry is the branch of science which deals with the study of carbon and the compounds of carbon. So now, let us begin this chapter. Organic chemistry is also defined as the chemistry of hydrocarbons and the derivatives. It is also defined as the chemistry of hydrocarbons and the derivatives of hydrocarbons. Okay. Now, why are there so many organic compounds? The reason there are so many organic compounds can be attributed to the tetravalence nature of carbon atom. Tetracovalency nature of carbon. Now, what does this tetracovalency nature of carbon mean? Now, we know the atomic number of carbon is 6. So, its electronic configuration is 2 and 4, which means there are 4 electrons in the valence shell of carbon atom. An atom of carbon has 4 electrons in its valence shell. So, these are the 4 electrons present in the valence shell of carbon atom. Because of the presence of these 4 electrons in the valence shell of carbon atom, these 4 electrons can be used to share with the 4 other electrons from other atoms or carbon itself in this manner. If I bring 4 hydrogen atoms this way and put one carbon in the center with its 4 electrons, then this electron pair, this one and this one, they can be shared. They can be shared, and this results in the formation of 4 single covalent bonds, and this is a hydrocarbon. This compound is called methane. Okay. Now, this is called tetracovalency nature of carbon atom, and because of this tetracovalency nature of carbon atom, carbon chemistry, the organic chemistry, is studied as a separate branch of chemistry. Now, next property towards unique nature of carbon atom is catenation. Because of the tetracovalency nature of carbon atom, carbon can form carbon-carbon single bonds like this in a straight chain, or it can form branch chains also, or it can form cyclic compounds as well, like this. Okay, so these are the hydrogens. These are the hydrogens. Oh. So this property of self-linking of carbon atoms through covalent bonds is called catenation. So this one is a straight chain, this is a branch chain, this is cyclic. Okay. Now carbon has a property of formation of multiple bonds as well. Now for this, let us take few examples. Now it can form single bonds in the case of alkanes, alkanes. Now alkanes are the homologous series of hydrocarbons with the general formula CnH 2n plus 2, where this n stands for a natural number starting from 1, 2 and so on. Depending upon the number of carbon atoms, if I put the value of n is equal to, say, let us put 5. So this general formula becomes like this: C5H12. So this compound, it is called pentane. Pentane. Okay. Now this is the molecular formula of pentane. So in this compound pentane, which is an alkane, it is saturated. Alkanes are what? They are saturated. They are saturated hydrocarbons. They are saturated hydrocarbons. Alkanes are saturated hydrocarbons. So if I draw the structural formula of this pentane, it becomes like this: carbon 2, 3, 4, 5. And the rest positions will be occupied by the hydrogen atoms, like this. Like this. If you count the number of carbon atoms, there are 5, and there are what you call, there are around 12 hydrogen atoms. So this is the structural formula of what? It is the structural formula of pentane. Okay. Now this same structural formula of pentane, same structural formula of pentane can be written in another form also. Pentane, the molecular formula is C5H12. Okay. So this can be written in another form also. 1, 2, 3. One more, one carbon here, it can be done, and the rest positions can be occupied by hydrogen, like this, like this, like this. So this is also pentane, but its correct name, correct IUPAC name, IUPAC name becomes what? It becomes 2-methyl butane, 2-methyl butane. Okay. So if you look at the previous example over here, pentane, it has a structural formula. This is normal pentane, N-pentane, N-pentane. Okay. And if you look at this formula just now, it is called 2-methyl butane. So N-pentane and 2-methyl butane, these are what? These are called isomers. Isomers. Now it is a phenomenon. It is a phenomenon. It is a phenomenon in which compounds, they have the same molecular formula. The molecular formula is same, but their structural formula is different. Okay. Now that is isomerism. Now next thing what I would like to explain you is the formation of multiple bonds. Carbon forms multiple bonds as well. as well. Let us see how. If I take one carbon, if I take another carbon over here, it has 1, 2, 3, 4, 4 electrons. Okay, 1, 1, 2. Just a second. 1, now these two electrons here, two electrons here, and two electrons like this. Okay. Now this carbon it has how many electrons? 4 electrons. This also has 4 electrons. Now this electron and this electron will share. This electron and this electron will share to form a double bond. Okay. And I can give two hydrogens over here. One hydrogen here, one hydrogen here, so that they share the electrons to form two single covalent bonds. This one is a double bond. Another hydrogen over here. Another hydrogen over here. So this sharing can take place like this. Okay. Now after the sharing has taken place, now we get a compound which is like this. Double bond, carbon, single bond with hydrogen, hydrogen and hydrogen. So you can see over here. Carbon can form multiple bonds also like this. Now this compound, if you can see over here carefully, there is a carbon-carbon double bond. One is a sigma bond, another one is a pi bond. The sigma bond it is formed by the head-on overlap. Head-on overlap. And pi bond is formed by the sideways overlap of the atomic orbitals. This compound is called ethene. It is called ethene. It belongs to the second member of the homologous series of hydrocarbons, which is called alkenes. It is called alkenes. Okay. Now similarly, it can also form triple bonds. Carbon can form triple bonds as well. Carbon can form triple bonds as well. Okay. Now let's take one example. One electron, 2, 3, 4. One electron, 2, 3, 4. So sharing takes place like this. Okay. One hydrogen here, another hydrogen over here. So electron over here. So let's check. 1, 2, 3, 4, 5, 6, 7, 8. Octet. They're also octet. So in this way we have a compound like this. Carbon-carbon triple bond, another carbon and hydrogen. One is a sigma bond and these two are the pi bonds. So this compound which you see over here, because of the unique nature of carbon atom, it is forming a triple bond as well. This compound it is called ethyne, and ethyne belongs to the homologous series of hydrocarbons which is called alkynes. It is called alkynes. Okay. Now let me explain the isomerism as well. Isomerism in hydrocarbons. Isomerism in hydrocarbons. Okay. I have already told you what is isomerism. It is a phenomena in which compounds have the same molecular formula. They have the same molecular formula, but different structural formula. Okay. Now, hydrocarbons in our syllabus, only structural isomerism is there. Under this, only chain isomerism is important. So, Remember, structural isomerism. Only structural isomerism there, in which only chain isomerism is required to be studied. Okay. Now, here let us see. Let us see over here. What is chain isomerism? So, chain isomerism or chain isomerism. Let us take one example. Chain isomerism. Let us take an organic compound, an alkane. Alkane with the general formula CnH2n plus 2, and I put the value of n is equal to say 4. Okay, so I will get C4H10. So this compound becomes butane because there are 4 carbon atoms, so it is but. Okay, now quickly I want to mention you about the word roots. Organic compounds having one carbon atom, the word root is meth. Organic compounds having 2 carbon atoms, the word root is eth. Having 3 carbon atoms, the word root is prop. Compounds having 4 carbon atoms, the word root is but. Compounds having 5 carbon atoms, the word root is pent. Compounds having 6 carbon atoms, the word root is hex. Then 7 will be hept, 8 will be oct, 9 will be non, and 10 will be dec. So you must remember this. These are called what? These are called word roots. Word roots. Okay. Now, this alkane, which is called butane, it has 4 carbon atoms and 10 hydrogen atoms. So let me draw the chain isomers of this compound. So first one, carbon, 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 4 of them, and hydrogen, like this. Hydrogen, hydrogen. So this is one structure. This is one structure. The same molecular formula C4H10 can be written in another structural form in this manner. 3 carbon atoms in a straight chain, and I do one branching like this. So this way I put the hydrogen, hydrogen. So you check. This is butane. This is 2-methyl. This is butane. Normal butane. This one is 2-methyl propane. 2-methyl. It is propane. Okay, so this is isomerism. Butane and 2-methyl propane are what? These are isomers. Okay. Now next I want to explain you about the homologous series of hydrocarbons. Now what is a homologous series? You will find the definition of homologous series in your textbooks as well. Now to define it, a homologous series is a group or a family of organic compounds having similar structures and similar chemical properties in which the successive members differ by a CH2 group. They differ by what group? By a CH2 group. So let me write down the 3 homologous series of hydrocarbons: alkenes, and alkynes. Alkenes, they have a general formula CnH2n plus 2. Alkenes have a general formula CnH2n. Alkynes have a general formula CnH2n minus 2. Okay, so alkenes, first homologous series. Alkenes are the second homologous series of the hydrocarbons. and alkynes are the third homologous series of hydrocarbons. Alkenes have all they have carbon single bonds. Alkenes have at least one carbon double bond. Alkynes have at least one carbon triple bond. Triple bonds in them. Now, please make a note that alkenes are saturated hydrocarbons. Alkenes are what? Saturated hydrocarbons. Whereas alkenes and alkynes are unsaturated hydrocarbons. Okay. Now, let us go in detail. Beyond alkenes and alkynes, outside hydrocarbons, we can have other homologous series called alcohols or halogen derivatives or aldehydes or carboxylic acids. But our syllabus is confined only to the study of the alkenes and alkynes respectively. Okay. Now, next thing I would like to explain you in detail is regarding over here the homologous series of alkenes and alkynes only. First, alkenes. The first alkane having one carbon atom, that is CnH2n plus 2. The first alkane having one carbon atom, if I put the value of n is equal to 1, I will get CH4. It is an alkane, ANE. Okay, so its word root is meth. ANE, so I put over here ANE, methane. Similarly, if I put n is equal to 2, then it becomes C2H6. This becomes eth. 2 carbon atoms, so the word root is eth, and it is an alkene, so ANE, ethane. Further, I can have n is equal to 3, so I will get C3H8. So it becomes propane. I can have n is equal to 4, so this becomes C4H10. Just put the value of n in this formula, so you will get the molecular formula, and depending upon the number of carbon atoms present in this hydrocarbon, use the word root for the corresponding number of carbon atoms and write down the name. So 4 carbon atoms, word root is but, and you write down A and E. Okay. And one more, for 5 carbon atoms, you can have C5H12. Now 5 carbon atoms, it is pent, and it is an alkane, so A and E. Please note that in all these compounds over here, all carbon bonds are single bonds. Okay. Now, the next thing is regarding alkenes. Let me give you idea about alkenes also. Okay. In the case of alkenes, we know the general formula is CnH2n. If I put the value of n is equal to 1, then I will get CH2, and this alkene is not possible because in this compound the combining capacity of carbon is not satisfied by 2 hydrogens. This compound does not exist. The next one is, put the value of n is equal to 2, I will get C2H4. So this compound, 2 carbon atoms, so the word root is eth, and it is an alkene, ENE. Okay, unsaturated. It is called ethene. If I put the value of n is equal to 3, It becomes C3H6. 3 carbon atoms. So it becomes prop in. Okay. If I put the value of n is equal to 4, then I will get C4H8. This becomes butene. Similarly, n is equal to 5. This becomes C5H10. This becomes pentene. Pentene. Okay. So these are the alkenes, the second homologous series of hydrocarbons. Now, the next thing I would like to explain you is about the homologous series, which is called alkynes. Alkynes. Now, the alkynes general formula you already know. It is CnH2n-2. Now, for the alkynes, I have told you these are unsaturated containing carbon-carbon triple bonds. Alkynes contain carbon-carbon triple bond over here. Okay. So put the value of n is equal to 1. You will get C1H0. Not possible. This one is not possible. Not possible. So it is not possible. Put the value of n is equal to 2. You will get C2H. 4 minus 2 is 2. H2. So this compound, it is 2 carbon atoms, 2 hydrogen atoms. So this compound is called ethyne. Ethyne. Commonly this compound is called acetylene. 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 Okay. Next is n is equal to 3. 3 carbon atoms. It becomes C3H. 6 minus 2 is 4. H4. So here we have got this compound 3 carbon atoms. It is called propyne. Propyne. So similarly, I can have one more. N is equal to 4. 4 carbon atoms. So this will be called C4H. 4 to the 8 minus 2 is 6. So this compound is called butyne. Butyne. So these are, what are these? These are alkynes, and they belong to the family which is called acetylenes. Okay. Now